So if you don't know, my name is Denise Payan, and I'm going to be teaching the fossils class from now on. We actually have 2 sessions left, including this one and the one next week. Um, so for now, we'll just get started, and if Connor shows up, we'll do a small review for him. And besides that, I think it's just going to be us. Are you ready to start?
What?
Okay. All right, so today we're going to be going over the major fossil groups that are going to be on the exam for the fossils in Science Olympiad. We're going to go over half of them anyway. Next week we're going to be going over the vertebrates, and this week we're going to be going over the invertebrates. So today we're going to cover only half of them. And I wanted to put this up here just to make sure that everybody who is taking the fossils class and is going to be competing in the Science Olympiad tournament has it. If you don't have this list of fossils that you should know by the time the tournament comes around, then you should definitely get it now. Today we're going to be covering up to phylum Echinodermata, and we're not going to be going over every single genus and class, but we're going to go over every phylum at least, and then some examples and some of the subclasses. So you do still need to do your own studying on your own time. Make sure to get this list. It's on the Science Olympiad official website under Division B events. Just go to the fossils and you can go ahead and download it. So hopefully everybody who is doing it has gotten it. If not, you need to get this as quickly as you can and study it on your own. Also, another really good source is Quizlet. They have basically every genus and species and every fossil that you need to know is on there, and it has a description of them, it has a photo, and it has their taxonomic categorization. So it'll have their kingdom, phylum, genus, class, and everything you need to know about them. That is the place where I got a lot of the information that I'm going to be presenting today, but I'm also going to be doing more of a general overview of some of the phylums. Okay, so let's get started. So the first thing we're going to go over is the kingdom protozoa. Now, a protozoa is basically a single-celled organism. And in this kingdom, you only have to know one fossil, and it's this one. And these are called fusunilids. And they're eukaryotes, and usually I identify the fossil because it's pretty distinct. They have this kind of rice-like structure. Whenever I say it, I think of rice. And each one of these is a single-celled organism. Sorry, let me get my pen. So every one of these is going to be one fusunilid. Change my color to something you can see more. So each of these is going to be one of the organisms, and they usually come in these tightly packed things that I believe look like rice. So it's kind of not that hard to identify, and their shells are actually secreting calcite, so they're actually fossilized from in their own limestone. So they do secrete calcite, which you should know by now makes limestone rocks. Okay. So we also have the period from which they lived, which was from the Silurian to the late Permian. I'm looking for my list of fossils so I can follow along with you. 1 second. Okay, here. So this is the only order you need to know in the protozoa, and the only other one that is that you need to know from kingdom protozoa is the next one, which is this. These are called nummulites, and these are large fossils that are also made up of small single-celled organisms. And they're characterized by their shape. They're actually called nummulids because because of their shape, basically. And to me, it kind of looks like a rose. And again, it's pretty distinct, so you're not going to have a lot of issues trying to remember what this looks like. And again, each one of these little small portions is going to be one fossil. So it's divided into chambers, and they usually range between 1/2 to 2 inches. And they're found between the Eocene and Miocene, so they're actually not that old. Okay. All right, so and that's basically all you need to know from the protozoa is those two, the order Fusulinids and the Nummulites. So that's done and done, and we can move on to the Animalia. And today we're going to be covering only the invertebrates, which means that we're going to be covering only the organisms that don't have a skeleton, and they have no notochords. So the first phylum that we're going to cover today is the sponges. They're called Porifera, or as you know today, sponges. So this is a phylum that still exists today, and a lot of these organisms still exist today also. So this genus it's called Astrospongia, and they have a saucer shape, and basically it's also a lot of it looks similar to what we have today. And one thing I wanted to mention is that this word here, stellate spicules, it basically means that if we zoom in really close to this fossil or to what this sponge looked like, it would have something that's shaped like this. Spicules just means like an appendage, right? So it would actually be 6. So spicules is just like an out pointing appendage. So basically something that sticks out, and 6 rayed just means that it has 6 of them that are even. So if we look closely more at the sponge that lived so long ago, then we would be able to see these little things that stick out of it. And this is actually an index fossil, and basically an index fossil, if you don't know by now, is a fossil that's found pretty widespread in places all over the world. So for example, if this fossil was found during the Paleozoic era, if we found this fossil in a rock formation in China and also in a rock formation in the United States, we can use this rock to estimate the age of other fossils and other rocks that are in the same rock formation. So it's an index fossil because it's found consistently throughout the world, and we know the date that it existed. So using that, we can use relative dating to find the ages of other rocks and other fossils. So this is a sponge, and it's pretty basic also. So moving on, this is also in the same phylum. Only this one is called Hynoceros, and this is actually known as the glass sponge, and it gets its name from the spicules. Also, again, the spicules just basically means these things that stick out right here. So this one you can see it because they're not tiny like in the previous example, but these things here that project are called spicules, and it has 6 radially that around the whole thing. There's going to be 6 of them. And this word here just means it has silicates. So it just means that this skeleton has silicates in it. And it was found in the Devonian era in New York and West Virginia. So usually their shape does kind of vary. You do have some vase, some spherical, some pear, but the thing that you're going to use to distinguish it are these bumps that we call spicules that project out of it. So that's going to be the defining characteristics for something like this. Oh, and so this is also known as a glass sponge. If you didn't know, silicates are kind of almost transparent color. So when this existed, you can imagine that this was a much lighter color, so giving it its name, the glass sponge. The common name, rather. Okay. So the next thing we're going to go over is the phylum Bryozoa, and this is also known as moss. So this, again, is just another phylum that still exists today. And the first genus we're going to go over is this Rhombopora, and this is an extinct genus of coral. So we have corals today, and if you look at the fossils, they look pretty similar to what existed millions of years ago. Okay. Do you have any questions so far, Kenneth? Also, if you need me to slow down or clear anything up, go ahead and ask me. Or if there's just, too much on the page, whatever it is. Okay. Okay, so this is genus Archimedes. Now this fossil very clearly is named after Archimedes' screw. I don't know if you know what that is, but there is actually a machine called Archimedes screw that it's used to transport water. So if you actually looked at the photo of Archimedes' screw, he was actually a mathematician, if you didn't know who Archimedes was. So Archimedes is a mathematician who is known for his geometry and his basically his contributions to the mathematical world. And one of those things is this machine that used to carry water. So this fossil looks just like it. I don't have a picture of it, but it looks just like this fossil. And so this genus lived from the Carboniferous to the Permian. And aside from that, it's pretty distinct too. And I thought it was one of the easiest ones to remember just because if you heard of Archimedes' screw, then you just look at this and think screw. And so you don't really have to do much to remember the name of it because it's named after a famous mathematician. Okay. Okay, so now we're going to go over the phylum Hemichordates. So in this phylum, you only have to remember, or you only have to know one class and one organism, and which is this. They're called graptolites. So graptolites, well, more generally, hemichordates are marine invertebrates that look like worms. And one thing that I wanted to mention, or that I have here, is that their name actually comes from the two different words, one meaning half and the other one meaning chordate. So if you know what a chordate is, that's actually an organism that has a notochord or a spine. So they basically made up this hemichordates, meaning that they're half chordates and they're half of, well, just basically that they're not fully chordates. So they look like worms, and one thing that people often say is that these fossils look like hieroglyphics. So if you know what hieroglyphics are, it just is an ancient type of writing where they used drawing instead of words. So if you have ever seen, like in movies, you have cavemen, drawing buffalo and little people in the walls of caves, then that is actually what hieroglyphs are. They're just using of pictures to tell stories or get messages across. And people often compare these fossils to that. And so these are colonial animals. They didn't live by themselves, and they lived from the Mississippian to the or in the Carboniferous. And you should be aware that the Carboniferous is just another word that they used in basically the UK is where they coined the word Carboniferous, and it covers the Mississippian and the Pennsylvanian periods. So if you hear that word, just know it means Mississippian and Pennsylvanian. So this is again another index fossil that was found. It's found pretty widespread around the world, so we can use that to help us date other rocks and fossils. And phylum Cnidaria. So this is actually going to be, we actually have quite a few different fossils that you should know in this section. We're not going to go over all of them, but in more general detail, Cnidaria are going to be characterized by their stinging structures. So if you think about things like jellyfish and anemones, those are things that exist today that are in this phylum. So when we categorize fossils into them, we're also going to assume that they have some of the same characteristics. So if we look at the genus Halicytes, we want to assume that they're going to also have some kind of stinging structure on them. And oh, and I forgot to mention, corals are also included in this phylum. So this is called more commonly a chain coral, and you can see why. Just based off its structure, it looks like it's a bunch of chains put together. And so it's found through the Ordovician to the end of the Silurian, and they can actually get pretty big. And even though they look like they're not really alive. I don't know if you've ever seen corals, but oftentimes I mistake them for plants. But they did eat. They fed on microscopic animals, so plankton, right? So besides that, in the Cnidaria. We also have Heliophyllum, and this is another type of coral, and it's known as a horned coral. So most of these are pretty obvious. Their names describe what they look like. If you look at this, we have our horn shaped here. And these parts in the inside are actually going to be something like if we remember what an anemone is. If you think back to Finding Nemo, that's what an anemone is, if you've ever seen that. They have these little extrusions that if you touch can sense food or whatever it is. Maybe it could be debris, it could be food, it could be another organism. So these things have tentacle-like structures that are going to have that stinging ability. So whenever a food falls in there, whether it be like a snail or some plankton or whatever it is, these corals are going to sense them, and then they're going to use their stingers to trap it, and to that's their food. And so even though we have a lot of them here, they were solitary. They didn't grow in colonies, and they lived during the Devonian. So that's pretty much all you have to know about these. One second. Okay. So there are a couple. There seems to be 5 different genuses that you have to know. And we're not going to go over them right now, but you should go on over them in your own time. So we're going to have horn corals and then the colonial corals, which you should know. Okay, and so now we're going to go over the phylum Arthropoda. And arthropods are one of the most common phylums that you're going to find. More generally speaking, arthropods are any animals that are part of this group. They're usually going to have these 3 characteristics. The first is that they have a segmented body. So if you look at something like an ant or a spider, you're going to be able to see it's going to have these different segments. So it's not going to be like any other animal, like a worm or a cat or something. It's going to have these very clear segments in its body, and it's also going to have jointed limbs. So here we have jointed limbs at this point where they bend, just like us. Is another characteristic that these arthropods have. And they often have an exoskeleton. It's rare that they don't, but usually they do, and they molt them. So every so often they will get rid of that skeleton and grow a new one back. So going on to the next one. So we have arthropods include a lot of different subclasses, including spiders, which are the arachnids. We have the crustacea. We have fleas and mites. We have harvestmen, which are known as daddy longlegs. So one of those subclasses that we're going to go into right now is called the crustacea, and this includes things like crabs, lobsters, krill, and barnacles. So these crustacean subphylum they're all going to be marine. So none of this lives on land. Well, crabs do, but they're still considered marine because they're on the coast of the ocean, right? And they're just distinguished because of their 2-parted limbs and their larvae. So unlike things like spiders or flies, which are also part of the arthropoda, they have very distinct babies. So if we look like a fly, the fly, when it has its offspring, it starts off as a maggot. Or if we look at a spider, it has an egg, and then when the spider comes out, it looks just like the big one, except a smaller version. So the first part we want to mention is its limbs. Here it has these 2 parts basically, and that's going to be true for every limb. It's going to have 2 main parts. So that's what distinguishes this subphylum. And then the other part is here, and this is a picture of the larvae. So these are called nauplius, and they're simple, and they don't really look like the parents because at this point they don't have a segmented body. It's more like a one one larger piece. And as they develop, those segments are made more distinct. And they have 3 appendages, meaning they have basically 3 pairs of arms or antennas that like stick out. So that's going to be the distincting characteristics of this. And they also, when they're small, they only have 1 eye, and we call that the nuclear eye, and it's located right in the middle rather than one on each side. And we also have, I guess, 1 terrestrial type of crustacean, and those are called wood lice. And they existed since the Cambrian, and they're still common today. So we have a bunch of fossils that look almost exactly like the living animals that we have now. So this could be something that we can call a living fossil, because they haven't changed that much in millions of years. These animals have done so well that they didn't really have a need to evolve. Hi, Connor. You're here. Connor. Sorry. All right. So a quick recap, Connor. Today we're going to be going over some of the invertebrate phylums really quickly. That's okay, Connor. You don't have to apologize. Really quickly, let me go back to this front page, and let me delete this. I just wanted to make sure that you have this download. It's available in the official Science Olympiad website, and it lists all of your fossils that you need to know. So today we're going to be going over some of the main phylums and the characteristics that they hold, and then we're going to be looking at some of the genuses and classes more specifically. Now, we're not going to go over all of them, so you should be studying on your own time, right? And I mentioned earlier that a good source to study is using Quizlet, and it's just, go to Quizlet.com and then type in Science Olympiad fossils. And it'll have all the fossils, all the classes, the genuses, and species that you need, including a description of them, when they lived, and their characteristics, and a photo, okay? So be sure to study that on your own time. Really quick, we went over the kingdom Protozoa. Kenneth, you lost your connection? Well, I'm just going to continue and review for Connor. Hopefully you can get back on and still cover what we have. I'll do a quick, okay, good, a quick review. So we'll move pretty quickly through these. Okay, so this first one is single-celled organisms, and they're called fusinillids, and they live in these compact rocks that kind of look like rice. Okay, so pretty quickly, this one, the nummulites, hopefully you saw the photos of them, and again, are single-celled organisms, and those are basically the only 2 you need to know for a protozoa. And then we went into the invertebrates, and we started talking about the sponges, and we started talking about these things called spicules, which are just projections. These are just projections that are that stick out of the fossils, and they're actually more prominent in the next photo. Let me move on. Where is it? Okay, so these things here, again, are the spicules, and they're just more obvious here because they're not, they're not microscopic. Okay, so just so you know, these are some of the more, these are just the defining characteristics of these fossils. Okay, and we went over the bryozoa. You actually only have to know this one, which is an extinct form of coral, and it looks just like what you might, see a coral look like today. And this one, which is the Archimedes genus, and it's named after Archimedes' screw. I don't know if you've heard of it, but if you just think Archimedes' screw, it's pretty, it's a good way to remember it because it looks just like a screw. Okay, and then the hemichordates are just these kind of worm-like fossils that we found, and that people often compare them to hieroglyphs. So these are called graptolites. Okay, and the Cnidaria, again, are going to be characterized by their stinging structures, and these things include animals that exist today, such like jellyfish, anemones, and corals. Okay, so Moving on, we've gone over the arthropoda also. Their main characteristics are going to be their jointed arms and legs, their appendages, and their segmented bodies. Most, but not all, have an external skeleton that they mold. Okay, so this is where we were now, which is under the subphylum of the arthropoda, the crustacean. And this includes crabs, lobsters, crayfish, and barnacles. So they're distinguished because of their two-parted limbs and their larvae, which are these here. So again, the larvae are going to be, not as segmented, and they're going to have these 6 appendages here, right? Okay. So moving on, this is class Insecta, and this is also going to be under the arthropoda. So again, we're still going to see segmented bodies, and we're still going to see the exoskeletons, and we're going to see their jointed limbs. So under this class, these are going to be air breathing, so these are no longer marine. Unlike the crustacea, which are mostly marine, these arthropods have their bodies divided into 3 parts, including their head, their thorax, and their abdomen.